1, 2, 3. Blah, 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 blah. Okay, sound check. Hey! I started on time this time. How rare is that? That's pretty nice. Oh, that is the wrong window. So, while I get things ready and put on my face, as it were, today's thing. Oh, that's right. I need to put it in chat. Let me do that first. Yeah. And then does this? Should. Yeah, there it is. Alright, so again, if anyone wants some tutoring last minute stuff, I'm pretty sure though that a lot of people might already be on winter break. So, maybe it's already too late, right? Maybe you don't need homework help. Maybe it's it's already a foregone conclusion. But in the event that you do need assistance... Oh, shoot, my mic. Is it plugged in? Yeah. Sorry, just trying to make sure I don't get cut out or popping noises. Anyways, as I was saying, so... Oh, what was I saying? I lost track of thought. Well, anyways. Oh, yeah. It's probably the end of the semester or the quarter. Might already be on winter break. Might not need help. Might already be too late, right? But, hey, you could still stop by and learn a thing or two. Ask questions. That's totally fine. But, yeah, I don't know if anyone actually needs help. I think a couple weeks ago, I went over test-taking strategies, which was, I think, very helpful. It's mostly focused on like the context, where if you have questions, multiple choice questions, then you could probably, use parts or inferences from one question to answer other questions that you already skipped. Stuff like that. But today is gonna be kind of old school, and I don't know. I feel like talking about algebra today because I feel like it's kind of undervalued, right? There's hey, there you go. It popped in. All right. So today is gonna be on algebra, and I hope I don't misspell it this time. No, I didn't misspell this word, but on one of my past streams, I misspelled a word quite obviously. It was kind of funny looking back at it. Alright. So. What's the deal with that? Well, algebra, I think, in a very general sense, it's like a bucket. Or a cup, or just like some kind of container, right? Not quite a loot box, but definitely something where you don't know what's inside, and it's just like a store of value. It could be 10. It could be smiley face. It could be money. It could be anything, right? It could be another equation. Who knows, right? But the point of... Oh, sorry, this is a variable. So, specifically, this is a variable where it is the store of value, and algebra is using math to kind of figure out these stores of value. And if we go way, way, way back, right? And even though this is a kind of a more simpler example, there's like these old like math problems and like... I don't know, like grade school stuff where it's like, hey, if one person has 3 coconuts. No, wait. What's a round fruit? What's a round food? Buns. Oh, yeah. Buns. Steam buns. It's like steamed hams, but they're buns. Alright. So the person has 3 steamed buns, right? And then they eat 2. How many do they have left, right? You'd say, oh yeah, that's 1. That's nice and easy, right? But when it comes to something like variables, then you could make this kind of a little bit more complex. You could say, well, this person, they eat 2 buns every day, right? And so then if they have something like, let's say, 3 days, right? For 3 days, they eat minus 2 buns each time. How many is that? And you're like, oh yeah, at the end then they eat 6 buns. Cool. Easy. Wait, no, I had an example. Darn it. I had an example in my head where it'd be like actually a clear variable and a use. Let me try again. Oh boy, off to a great start. A store a value variable. Okay. So, a person is eating 2 buns a day, and instead of you knowing just the full picture and you getting the here, right? What we end up having is we could use algebra to kind of solve this when we don't have all the information. Maybe we don't know how many days it's been, right? And they got into the bun vault and they just been eating every single day. And now there's like minus 20 buns, right? How many days have they been in there just eating buns all the time? There we go. That's how you do it. That's the example I was trying to get to. And so unlike maybe addition, subtraction, multiplication, division, where you have in numbers and you try to get the answer, algebra is where you have the answer first and then you substitute unknown numbers with a variable to store it, and then you work backwards to find out, well, what is going to be this? Now, what's the whole point, right? Well, then let's put some more practical examples to it. And my favorite example is money, because I think, you know, money and math are pretty interlinked, right? And, you know, in a similar example, we could say, all right, this person has $30. And they want to buy something that costs $20, right? How many dollars are they going to have at the end when they buy it? 10. Kind of parallels what's going on here, right? And then, in a similar way, right? What if someone spends $20 on, let's say they're buns? I may or may not be really hungry right now. So let's say each bun costs 20 bucks, right? No, God, that's ridiculous. A container of buns. And it doesn't matter how many. Just enough to feed for the day. A day's worth of buns is 20 bucks, okay? Let's work with that. So, 1 day. So then if this person's gonna be spending $20 a day buying food of buns, sure. Then let's go and say, well, if there's 3 days and they are spending about $20 worth of buns. Whoops, that is not correct. I need to put the dollar sign here. Then how many buns, or how much money have they spent eating buns in these past 3 days? So then you just do 3 times minus 20, yeah, negative 60. Why do I keep doing that? Then you're out you're out $60 because you've been spending $20 of buns per day eating, right? And again, this sort of parallels this example where we're just being silly. But now let's kind of ramp it up a bit. And instead of saying negative 60, let's take out the 3 and go to negative 200. Now, when talking about money, negative 200 is kind of a lot of money, right? And you might think, alright, so this person's going to be out $200 because they're going to be eating $20 worth of buns a day. How many days has this been? And you might, again, be able to see the parallels of my earlier, more kind of silly examples. But when it comes to something like this, this is why algebra is important, because what it does is it teaches budgeting. So that's kind of the greater point what I was trying to get to, is that algebra is a tool for using stores of value and variables to get equations, and you might, do a lot of complex stuff, but in a very it is a way in which to use and manipulate numbers to be able to find out your budget for whatever it is you're doing. Yeah. So let's just solve this example really quick. Right, how do we solve for, and let's change it to something that doesn't look like a multiplication, smiley face. Because again, in algebra, these are just variables, right? People like to use things like a or b or c or x or y or z, but you can actually just use whatever. Kind of. When it comes to maybe homework or classes, you got to use the variables that they teach you, right? I'm pretty sure if you just substitute like the Pythagorean theorem with like smiley faces and stars, you might get the answer, but then it's difficult to kind of follow the work because the equations you're using look a little off. But when you do whatever it is that you're doing, like budgeting, it really doesn't matter. So I'm gonna say smiley face times 9 minus 20 buns a day, but I'm gonna be out $200. Or rather, maybe I have $200 to budget for food, right? And so maybe I plan to go someplace. I say, okay, I need to have, I can only have $200 for food to go to this place to eat, or to go on this trip, or to go to this visitation, I don't know. And you kind of set your budget there. So then now you can work backwards to figure out, okay, how many days can I actually stay on this trip and kind of be okay and be within the budget, right? Let's say, for example, I'm going to go on a week-long trip, 7 days. And I know what I like to eat, and I know how much it costs. I say, okay, well, is $200 enough? Is it too little? What if I want to get extra? How much extra am I going to have? What if I go over budget? Then I'm going to get like an overdraft fee, or it's going to be on the credit card, and that's not good, right? So, again, we'll use algebra to kind of take out the stress and solve this. And so to solve for smiley face, how much food, how many days we can actually, eat, we do minus 20, we divide it by both sides. Because what we want to get is we want to get this variable by itself. Because here's a very easy one, right? 1 equals 1. Hey, cool, alright. It makes sense. But if I say x equals 1, then you're like, okay, well then that is what x, this variable, it's going to be this number. So then if I plug it into something like x plus x, what does it equal? Well, then you could kind of use this equation. Alright, well, there's x and there's 1, so it's just 1 plus 1 equals 2. Ah, I love it. Easy peasy. Now, what if we just make it like overly complicated, where it's just like x to the power of x plus x divided by x with the square root. What does that equal? It's like, oh man, well, let's try to figure this out. So maybe we want to try to figure out, you know, each of these separately, because they're basically equations within an equation, right? But you just kind of plug it in, where you got 1 to the power of 1, which would be 1. No, wait. Well, actually, yeah, it would, huh? Because I think it's when things are to the power of 0. But I mean, that doesn't count, because it's already 1. Yeah, okay. We're fine. We're good. 1 to the power of 1 equals 1. So, we got that solved. Boom. 1. How about x up here? Don't be daunted. The answer's right here. It's just 1. Alright? And what about right here? The square root of 1 is, I think it's 1. Pretty sure. Yeah. So we got 1 divided by 1 plus 1, which would be 2 over 1, and 2 divided by 1 is 2. So our answer is 2. Once again. And the reason why I bring up this kind of more complicated example is because the thing is that what if we didn't have this part, right? What if we didn't know? So then what you want to try to... Well, actually, no. I don't want to do it with that one. That's way too complicated. Let's just do x plus 2 times 3 equals y, right? And we want to solve for x. But we want to also, you know, you have the y hanging out there. Okay. Now we can do stuff. So a couple things we could do is if we didn't have the y, right? What we could do is we could kind of move the 3 into each of these. I believe. And then we'd get 3x plus 6 equals y. But I think the easier way would just be to kind of, you know, divide the whole thing by 3. So then what we could do is have x plus 2 equals y over 3. Because then, you know, what we have to do over here is we do minus 6. And then we would get... Oh, my head's in the way. Although, again, it might be easier in this case to kind of split them up. That's if you're just solving for something else. Both of these are going to be the same. They're just doing things in different order of operations. Somewhat. Whoopsie daisy. That's not the movement thing. Okay. 3x equals y minus 6. Divide by 3. Divide this whole thing by 3. You get x equals y. Divide by 3 minus 6. And here we have... Yeah. X plus 2. 2 minus 2 minus 2. X equals y divided by 3 minus 2. Right? And again, even though these kind of look slightly different, they're actually still the same equation. Because you would just kind of put the 3 into here, then it become y divided by 3, and you can put the 3 into here, and then 6 divided by 3 is 2. So, again, seems a little funky. And then if we get a variable for y, we can solve it. Let's just say it's, I don't know, 3. Sure. In either case, if y equals 3, then x equals negative 1. Sorry for skipping ahead there. I should probably explain that a bit. You would plug in the y here, so it'd be 3 over 3 minus 2. 3 divided by 3 is 1 minus 2, and then there you get that. If you plug in y over here, then you get 3 minus 6 divided by 3, which equals negative 3 divided by 3, which also equals negative 1. Okay. Now, that is some algebra stuff, but the way it works is that you can kind of have fun and manipulate the numbers. You can have multiple variables, you can have multiple unknowns, but you can still kind of figure out generally what it is you want to do. To that end, the reason why this is all helpful is because then it results in, you know, here's a simple example, right? Where we have a budget that we're trying to figure out, and ultimately, a smiley face, the number of days in which we can get food at a $20 spending per day on a $200 budget would equal about 10 days. Because you would just cross out the zeros over here, cross out the 2, those become 1, negatives cancel out, and then you're just left with 10. But also because there's a dollar sign, right? You're dividing by 20 bucks. The dollar signs also cancel out. so you're literally just left with 10. Nice and easy math. Alright. Now, could you have something like this with budgeting? I think it's like, oh man, this kind of algebra is kind of poopy. Yes, you can. So let's say, for example, we have X is the money you have in your savings, and Y is a number that you're going to get in your next paycheck. Good enough. Alright. And then you want to figure out, okay, can I afford this thing I want to buy, or do I have to wait, right? And before you even look at your savings or your paycheck, right, you'd have savings plus paycheck, and is it greater or equal to this thing you want to buy? Let's say it's, I don't know, what's a console? What's a popular thing? Actually, let's say if we want to buy a Steam sale video game that's on 20 bucks, right? And you don't know what you got, right? But you could kind of finagle with these numbers. You kind of mess with them. Nah. Okay. Sorry, working backwards. Here is kind of a basic simple formula that you're actually using in your mind as you think about how much money you got to buy this thing that you want. Maybe you don't think of it as a formula as you're thinking it through. Maybe you don't realize, oh yeah, this is a variable, this is an unknown number. As you're looking at this purchase you're thinking of getting. But if you wanted to budget, if you wanted to plan ahead, if you wanted to expect something and kind of have it written down in a way that you can solve and have an answer for, then this is great. Oh yeah, it's super handy. It's excellent. You got your savings. Okay, do I have enough? Your paycheck. Okay, do I have enough? And this thing you want to get, right? And then you could make it even more complicated. Like maybe let's say you got a. Can I highlight this? You also got to figure out like something like expenses. It could be anything, right? Bills, yeah, bills, expected expenses, anything. And then you can figure out, okay, well then, even though I'm getting these two numbers added, this number is going to be a minus. Am I still going to have enough at the end of the month? At the end of my savings and my paycheck, do I still have enough for this, right? And so this is kind of like a formulaic way to look at those kind of everyday questions that you might have when you're budgeting. And again, it could always be more complicated. Maybe there's more stuff like you want to make an equation that shows paycheck per certain amount of time. Maybe it's only for like a limited time that you're going to be working at this because it's part-time work. Or maybe it's variable, right? Maybe there's like a range of numbers. So it's not just like a solid number. It could be like maybe 1 through 100. I don't know. But for now, as a very kind of simple equation, trying to keep it basic algebra, not overcomplicate it. This is something that you can use. Not financial advice, by the way. Just trying to show the relevance of algebra within the scope of why is it important. Because when looking at things like geometry, trigonometry, calculus, and stuff like that, then that's kind of more getting lost in the weeds of just like all these numbers and equations and you know, graphs and all this stuff. But for basic algebra, it's super handy for things like budgeting. And where was I going with this again? Right. Okay. Now, this is budgeting for an expense that you're looking to do, right? But the longer term that you can use these formulas or algebra to kind of really budget maybe on like a larger scale, the more helpful it kind of gets. So, let's take something nice and boring like a spreadsheet. Ooh. A boring spreadsheet. Alright. And let's look at some expenses. Let's look at food, rent, income. No, wait. Let's put the positives at the end. Transportation. Actually, wait. This is a drawing program. This isn't an actual spreadsheet. Wait, let's get a little creative. All right, for food, let's put a hamburger. Yeah. Okay. Well, it kind of looks like a hot dog. Maybe both? Hamburger, hot dog? Alright. Let's see. Rent. Let's draw a picture of a house. Transportation. Let's just draw a picture of a car. And let's just type in, ooh, not type. What are bills? Now you want to kind of, like, the more you kind of categorize them and kind of separate them, I think it's more handy. Because the car would have its own bills. Categorically, yes. Like regular maintenance and gas, but it also have things like registration. So I'd still kind of keep that under car. Because ultimately, if you don't have the car, then you don't have to worry about all that stuff. But if you do have the car, then you do. So let's do... Oh, even better. Is that a good-looking phone? That's supposed to be a phone. Okay. Yeah, you hear from the top one and you talk into the bottom one. Okay. That doesn't really look like a modern phone though, does it? What about a rotary phone? Yes, I know that maybe some people are super anticipating this spreadsheet and anxiously waiting. Oh wow, what are all these things? But it's also fine just to have fun when budgeting. Draw little doodles. Because the money ain't going nowhere anyways. Alright. Let's see. Phone. Fun? Let's do a fun budget. Sure, why not? Yeah. Alright. Food, housing, driving, phone, fun. There's also, I guess, insurances. So I'm just gonna put that as like health. And then savings. It's a responsible thing to do. A lot of people don't have savings. It's very unfortunate. But the money is always gonna leave at some point. Savings is just kind of like a way to still have that money be used towards the thing it was going to go to anyways, but on a time scale in which it is, you know, not so urgent and you're not freaking out about it, where it's kind of almost expected. Technically though, if you're running a budget, this whole thing, this whole process of like budgeting, this is all savings. That's great. Man, how did I keep getting into finance? Because algebra has so much in common with it, that's why. Okay, not financial advice. But, because the thing is that if you're just spending money and you're not looking at it, that's not saving at all. But even the act of budgeting, just kind of taking a gander at what you're spending money on or what you're not spending money on, will help you develop a savings plan. I think a great example is, oh, what was it? It was a story about a guy who was living with his roommate, and you know the roommate wanted to go out to eat, and he's like, "Yeah, let's go out to a restaurant and have a good time." But the other guy was like, "No, I don't have the money for it." He's like, "What? What are you talking about? You have like a jar full of money right next to you. And you're saying that you can't go out to eat? Just take that money." He's like, "No, actually, this jar is money for rent, so I can't use it to go out to eat." He's like, "Oh, okay." I think that I remember that story being a lot funnier. Probably because I told it incorrectly. That's fine. But the point is that sometimes people can have like a jar full of money and say like, you know, I can't spend it. And that's because they're saving it because they have a budget where this money might go to one thing, but then there's no money for fun. And that can happen, right? But this is the responsible thing to do because ultimately he will still have the place to live even though he doesn't have the place to go out. If it was the opposite, right? Where he had money for fun, but no money for you know, rent, then he'd kind of be out of the place kind of quickly, depending on the localities of, you know, evictions and whatnot, and the rules going around that. I don't really know, but I imagine that it would not be good. And we would use this idea to realize that all this money, any kind of budgeting that's getting done, is saving, and it's also algebra. Because what you're going to have is you're going to have, at first, all these unknown variables, right? You're going to have the hot dog variable, you're going to have the house variable, the cart variable, And in a similar way, these are all going to be just unknown values. They're just going to be, you don't know. But as you take away the mystery, as you're able to put numbers to these things, as you're able to put, values to them, and say, oh yes, this equals that number, this equals that number, this equals that number, then you're able to kind of figure out, okay, well, if I don't have anything in saving, but I don't have any expenses this month, and I'm going to get $100, can I afford this game I'm going to get? Yes, you can. Cool. There it is. And you're not going to sweat about it because you already know what numbers are. It's less of a mystery. So, basically budgeting is the process in which you're looking at all these unknown variables and you're putting numbers to them just like how you would in an algebra formula, so then that way you can solve the equation to figure out, can you get the things that you want? And if you do it right, yeah, you probably can. Hopefully. I hope so. But to the process of this, how does this thing work? Well, like I said, it's a spreadsheet, so you're gonna have like a nice kind of grid. And you would split this up into whatever period you think is most workable and makes sense. Button. Okay. So for example, some people might do it by pay check, and maybe they get paid weekly or every 2 weeks. That's fine. Let's go with that. 2 weeks per box. And then you're looking at, okay, how much are you spending on food, right? And if it's just the same number, you get the same thing every day, all the time, that's nice. That's a nice workable number, right? If you are varying out when you do go out to get food and things, then you're able to kind of see that pattern though, where maybe there is a range. So let's go with the range example because that'd be more interesting. Let's go back to 20. And so you kind of look at your past spending and you realize, wow, one of these numbers is not like the others. I wonder why. What happened then? Oh, yeah. Maybe it was a friend's birthday. And they wanted to go out to eat someplace really nice, and you treated them, and you also paid for yourself and a bunch of other people, and it was pricey, and you're like, wow, that was a lot of money for that one time. But here's the thing, right? Because you're budgeting, you can kind of set an expense for that. Because here, if you were to put it into a formula like this, let's see. You can't really say that. Let's see if I actually select this. Sorry about that noise. Okay, can I make this thing bigger? Oh, I can. Oh, that's so cool. Sorry, I'm still learning this program as I do it. Yeah. Alright. So, say for example you have the food, you cannot say, even though for the most part you would spend this amount of money, $20 a week on food, sure. You cannot say that this is a true constant and that you don't ever have to budget for anything else, because there's a clear-cut example wherein that was broken. And there is a pattern where this is not just like a random one-off occurrence, this is a birthday. It's going to happen every year. So then you can't say, okay, well, I'm only going to need $20 forever for food. Nah, that's not quite true. If you want to celebrate in the same way, with the same people, in the same kind of place, with the same amount, and you think that is a fair amount to do, that's on you. But to help you get there, then you have to adjust this number to be something more reasonable and realistic. In that, you can kind of take an average. So, let's say, for example, this is like a... I don't know. I'm going to pretend this is a year. This is not a year. There's no, like, 6 weeks in a year. But, for example, right, we're going to pretend this is a year. Sure. Why not? For here, then we would do each week, right? Times however many it is, plus the one-off week, which is technically be multiplied by 1. That does not look like multiplied by 1. How do I do this? 1 times... I think they use the dots in algebra, or is that like calculus? I forget. But it would be something like this, where you have the number of instances where you're having regular food, and the one-off instance where you're having that one birthday, because maybe even if this is like a month and you celebrate someone's birthday every month, then you have to kind of calculate that expense. And then you would divide the whole thing by, actually, oh, we can make this even more into an algebraic formula. Why not? Maybe this is what you normally get, the burger, right? But then for the birthday, you have the cake. That is not a cool looking candle. Alright. Well, there we go. We have, copy, paste, shrink. Okay. So I can solve an equation, right? Even though I can give an answer. The important thing is actually not the number which I'm trying to get, which is a little backwards, because normally in algebra you want to try to figure out, okay, well, what's the answer to this equation? That's the thing. That's the class, that's what you do. But here, into showing the importance of how algebra can be used for budgeting, I think it's important to actually go backwards to where I can say, alright, well, here's these fake numbers, but this is kind of a formula in which you could find things out. Let's just go with x and y. Where x is the number of times in which you eat hamburgers during a year. Y is the number of times in which you go out to celebrate a year. And z is... Actually, no, wait. Then I'd get the average, wouldn't I? Yeah. X plus y. I think that'd work. Let me think. Yeah. And then z is the average of how much money you're really spending each time. So then, again, and you could leave it kind of ugly like this, because once you have the actual numbers, once you actually have the spreadsheet with the values, right? Then you could just kind of like count and plug it in, and it's super simple. Like 1, 2, 3, 4. 5 times it's 20, 1 times it's 100. And then from here, from the formula, then you go backwards and kind of get this thing, right? Although I kind of did that equation wrong. So let me scoot this. if I can. Please. Yeah, there it is. Divided by 5 plus 1. And then let's make this into a money symbol. Alright. And there it is. And so, assuming with these fake numbers that we have, using this equation that we built backwards, from understanding and then reinterpreting what we think in our minds of, well, how much am I spending on food, really? Because it's not just this number that I thought, it's probably going to be a little something extra because I celebrate birthdays and celebrations. And then by kind of getting an average, we can kind of figure out, okay, well, what's this going to be? And this, just kind of eyeballing it, looks like it's going to be 100 plus 100 divided by 6? Is that right? Yeah. 200 divided by 6. And then I'm just going to bust out the calculator for this one. No way. I did that wrong. Alright. Oh, wow. What a nice, clean 33.33 repeating, of course. But that is the real amount of money that you're spending over here. So they can't say that when you go and do things, oh yeah, I'm only going to be spending $20 at a time. It's probably going to be more like $33.30, 33 cents. Okay. Oh, what can I do with that? Well, now you can kind of figure out maybe something here, back to our other example, of how much money you're actually going to really need for these 7 days, right? Because what if you did want to splurge a little bit? What if there was going to be a birthday, and it was going to be a birthday during this trip, but you've been saving and budgeting all year? Can you still afford it? Is it still going to be okay? Well, let's see. If we do, let's sticking with our smiley face variable of, instead of the old value of $20 of eating a day, now you have the new average, because you want to keep that average spread throughout the whole period. And again, this is just an idea, right? Not financial advice. Different formulas work for everyone. You got to figure out your own algebra formula for budgeting. Highly recommend it. But in this example that we're working with, we're going to do negative $33. And is that going to be enough if I'm going to have, you know, minus $200? Right? How many days can I actually spend on this? Pardon me. So with that, unfortunately, it's a messier number. It's not as clean and canceling out like this, where you can just get a nice, pretty 10. Instead of those 10 days, when you want to have a 7-day trip, now you're going to be looking at something like 6 days. And we can kind of figure that out because how we got this was 200 divided by 6. Again, this is using context clues, right? I already did the math here. I already know what the answer is. Cool. And we could swap out those numbers too, where also 200 divided by 33.3 equals 6. They're kind of interchangeable. Anyway. So, to that end, if I'm going to be using that kind of formula, where I want to divide both sides by 33.3, then my budget for the 7-day trip, which I thought I had in excess of 10 before, is now going to be 6. Ugh. Which is 1 day short for that 7-day trip. Now, that's not to say that when you encounter this sort of thing, that you should say, oh, I need to cancel my trip and everything's lost. No. No, it just means that you should have reevaluate, try to forgive yourself and figure out, okay, well, what can I do going forward in order to make sure that I have enough money allocated for food on trips next time. And again, it's very flexible, because I'm not saying that, every time you have to go on a trip, you have to take the average number. No, if you know exactly how much you're going to spend and you have an amount, and you're just trying to figure out the days, then this is actually a fine example. It really works. But if you're planning vacations in advance, and you're thinking, okay, well, how much time do I have allocated for, and you're going to be there for 7 days, but on average, you feel like you're going to be spending 6 days, and every day that you're don't have extra money saved, then that's going to be money that you're going to have less for when you have those major expenses, like a birthday. Yeah. What else? So this is just kind of a very, very long, windy explanation of ways in which you can use algebra as formulas, as stores of values, so you can kind of create your own equation to kind of figure out personal budgets. But going back before that, that is also to explain why algebra is important and why you have to learn all these funky things like, splitting numbers and whatnot, because this complicated process of trying to find a result will still help you get familiar with and working on algebra to, use it and manipulate it and change it and alter it and move things across and have things balance out. But it's also, makes budgeting easier, because instead of having just this complicated equations like this, once you actually know what the numbers are, you could plug them in and solve it and figure out, okay, then I need to have this much money per week, per period, allocated for this expense. Burgers. Yeah. And ultimately, that's all what algebra is. It's just using stores of value, just unknown numbers, where, in your head you might think, okay, well, do I have enough money for this? And if you ever had that kind of thought, then that's basically the unknown value of, what am I able to get? And until you have that value as like a clear-cut number, it's kind of just a variable. I'm repeating myself. My apologies. How do I put this? You don't have to make your mind think like an algebra and formulas and stuff like that. As you think and as you do stuff. That'd be interesting. Kind of a little silly though. Rather, it is for formulas to allocate future spending, future thinking, future planning, wherein you could actually have variables and then also plug them in with hard numbers, and then you get answers for getting the result that you need. Because in something like school algebra, you are given the numbers to find the result. Someone gives you the formula, gives you the numbers, and say solve for this. But in kind of life algebra, you shouldn't think of, okay, well, I need this to get this, Rather, you gotta kind of work backwards where you're like, here is the end result that I want. I want to not have to stress about buying cake for a friend's birthday. And so with that end result in mind, then you work backwards and you make the formula. And then that is why this works, because then you could just plug in the numbers and get an answer for what you should do on a short-term basis, on a regular basis, to get long-term results. Oh. Alright. I think that's kind of the gist of what I wanted to say regarding algebra. Now, of course, if anyone has any questions, feel free to ask. Still got time. Plenty of time. Huh. That's okay. Should I just end early? I don't know. Is there anyone even in chat? Ay. It says there's one viewer, but I think that's me. I don't know. But if it's not me, and it is a viewer, hey, thank you for sticking around. I really appreciate it, and I do hope this helps. And if you don't want to chat, that is totally fine, right? Because I'll just be here every Tuesday like a weekly TV show. Just trying to get on with it. But if you do ever want to chat, if you ever want to ask questions or have ideas or something that's kind of, you know, tangentially related to like a math or tutoring or studying, then hey, I would welcome it, right? And I'm not a financial advisor, but you know, if you want to talk about something about finance, it's kind of the same thing. You know, maybe derivatives. Derivatives. This is not quite like everyday finance, but it's technically finance. It's just like high level, you know, stuff. Specifically the trajectory of, I think, stocks and evaluation of things. I forgot. It's been so long. But it's there, right? Let's see. Yeah. What time will I be back? Is it? No, it's gonna be before Christmas. Wow, the 23rd. Alright, sweet. So, I will be here again next Tuesday on the 23rd. And if you or anyone else wants to talk about math, tutoring, and whatnot, feel free to say so. I have the chat set up so that I kind of like, you know, squiggles and appears like in the middle of the screen. So I think that's kind of fun. Yeah. And until then, I think I'm gonna say goodnight for now, because I'm kind of rambling and out of ideas for this particular subject. And of course, if anyone wants to look at past videos, like an archive, I actually have an archive. It's on YouTube, where you can look at all my all my past good advice mixed with horrible mistakes, all in one big pile mixed together, because this is not a professional production. So there's that. And then I guess shorts, which kind of highlight some of the better parts or some of the silly parts. Feel free to check those out. And yeah, have a good afternoon, evening, night. It's nighttime. Yeah, it's nighttime. Have a good night.